So build is called whenever you call setState, and you learned that build now rebuilds this widget and all its child widgets. And that's really important. If you call setState, only the build method of this widget is called, but then, since this code is executed, and we have a couple of widgets which we create in that build method, as you learned, new instances of these widgets are created, and whenever a new instance of a widget is created, its constructor and its build method is called as well. So when we call build here in the main Dart file, that means that also all these widgets down here will be created and their build methods will execute. Now, you have room for optimization here, and I'll come back to that, but generally that is what's wanted. That is how it should work. The idea here, of course, is that the configuration, because remember, the widget tree is all about the configuration, changes, and that then leads to a new output on the screen. But how does this actually work then if the widgets are replaced with new instances? Does this mean that the elements and the rendered objects, remember, these are the other two trees, also rebuild? Back to drawing. We had these three trees. We have the widget tree, we have the element tree, and we have the render tree, so to say. Now in the widget tree, we have a stateful widget. So our own stateful widget here. Now that stateful widget, of course, might have a child widget, which means it's using some other widgets in its build method, for example, a container. And that container then also might have a child widget which we nest in there, which is a text widget. And that's a very basic widget tree here, of course. Now, as you learned, when Flutter first encounters this, so when the app starts typically, it will create elements for that. So it will create a new element here for the stateful widget. It will create one for the container, and it will also create one for the text. So these elements are created automatically. Now, as you also learned, it will also render something on the screen. So it will then, once these elements are created and so on, also go ahead and create the actual render objects which control the content on the screen. Now the interesting part happens. In our stateful widget, we call setState. So something changes there. Hence, the build method gets called in the stateful widget here. So here, in this widget, we call the build method because setState was called. Now, what's actually happening here is that, first of all, we have to realize that the state is managed in a separate object, as I showed on the slide earlier. So the state is connected to the element and not directly connected to the widget. So when you call setState, that edits this state object. Now the widget then, once setState is called, is marked as dirty, which means it's basically replaced with a new one. So we get a new my stateful widget, which reflects that new state. So that new state we have stored in that state object here kind of ends up in the new widget. And with end up, I mean its output there or passed down to the children there or whatever you're doing with your state data. This new myStateful widget replaces the old one, which was removed because it's dirty, it changed. The state object here, however, this one, does not change. It stays here, it's not replaced. It's still the same object as before. So the state object is detached from the widget object. The widget is replaced when the state changes. The state is not replaced. And that's of course important because your state, your data, which changes over time, should be able to change over time. It would be bad if that would be swapped out for a new state object whenever you try to change it, because then changes basically wouldn't be possible. So instead now, we got a new stateful widget, and there the build method is called. And the build method being called, of course, also means that we rebuilt this entire widget tree. So for the container, we get a new instance, and for the text, we get a new instance. But what does this now mean for the element and the render tree? Since we have 3 new widget instances, and with this I really mean 3 brand new objects stored in memory. Does this mean that the elements and the render objects here also are replaced? No, it does not mean that. The cool thing is that the elements hold a reference at a widget, and they also, so to say, hold some information on how to identify their related widget. The first important piece of information each element has is it knows its position. So it knows which child elements it has. So it's basically like a skeleton for your widget tree. Your widgets have a certain structure, your element tree replicates this structure and actively stores that information. And in addition to that, otherwise this first piece of information would be useless, an element knows which kind or which type of widget it was connected to. So this here knows it was connected to the myStateful widget. The second element knows it was connected to the container widget, so to a widget of type container. And this last element here knows it was connected to a widget of type text. So now every element here in the element tree knows which child elements it has, so which connection to other elements it has, and which type of widget held the configuration for the element that should then actively be rendered to the screen. So since that is known, when we get a new stateful widget up there, which replaces the existing one, what Flutter does is it checks in that position of the widget tree or of the element tree, which is kind of the same here. Do I have a myStateful element here? Because I'm getting a new myStateful widget. And if the answer is yes, like it is here, then this means that the element is kept and it simply updates its reference to now point at the new widget here. That's what's happening. The reference of the element is updated. The old reference is cleared because the old widget was cleared. And now the existing element simply points at the new widget. And it then passes this information on to the render object, which is also kept, so that the render object can update in the places where it needs to update. So for example, if the background color is the same, but the text changed, the render object will only re-render the text pixels on the screen, so to say, and not everything. It doesn't lay out itself again, and so on. And this is why Flutter is so efficient. It has this element tree, which is not rebuilt whenever build is called. Only the widget tree is rebuilt, and the element tree can automatically update its references to know if a new configuration is available, and if that is available, it passes that information on to the render objects so that these can re-render on the screen. Now, if you want to learn even more about how Flutter manages all of this internally and which optimizations it puts into place, you find an interesting article attached to this lecture where you can dive way deeper, but this is basically how it works. And this is why calling build or having the build method called does not mean that the entire screen re-renders, because Flutter has a couple of layers to manage that, and calling build or the build method being called only means that this widget tree, so that tree of configuration data rebuilt or parts of that tree rebuilt, and therefore Flutter now checks which parts on the real screen need to be updated.